Sorry for my skin color. It somehow got lost in the upload. So I'm a little bit green, but I'm healthy. So I will talk about GPT-3 and AGI, naturally. GPT-3 stands for Generative Pre-trained Transformer. So that's the third generation, and AGI, of course, for Artificial General Intelligence. And the views I present here are my own, but the internal workings is sort of not my own. I'm not working on GPT-3. I'm just presenting it. So I believe the reason why I want to present is because I believe this can inform the philosophical discussion. I mean, you can study a lot and get answers from behavior, but it's also good to know a little bit about the inside working of these systems. I will not talk much about the applications, a little bit about the limitations, and very briefly about some philosophical questions. I leave that to my proper colleagues, proper philosopher colleagues. I'm not a philosopher. And at the end, if I have time, which I probably won't, I will talk a little bit about my research and AGI related other research. Okay, so let's get starting. By the way, this picture is a word embedding, and I will show you later what that means. So GPT-3 is a language model, and it's a probabilistic language model. And the old language models and also GPT-3 work like this, roughly speaking. You have a sequence of input words, say, for instance, here, recite the first law. And then the language model outputs a new word, like A. And then you put this word on the input tape, and then it outputs a new word, robot, and then it gets back to the input, and so on. The other language models where you put in a whole sentence and it outputs a whole sentence, the first transformer models have been of this kind, but GPT-3 is in a sense simpler than some of the previous models. And by the way, can you see my cursor? Okay, good. So the first thing, so these language models are huge neural networks in general, and we have lots of parameters and you need to train them. And what you do is you take a large corpus of text, you input it, you see what the language model outputs. Initially, of course, it outputs garbage, and then you adjust the parameters a little bit so that the probability of the correct word gets a little bit higher and the probability of wrong words get a little bit lower. And you do that over and over again. And then hopefully once the network is trained, if you give it some known text from the training set, it will output with high probability and recite. So the previous text, not exactly because it doesn't really store all the text, but roughly speaking. So at inference time, you freeze all the weights. And again, you give a piece of text as input. And then the language model gives an output, as I said before, and then you put it on the input tape, gives another output, then outputs robot, and so on. So that's how you do inference. Well, more precisely, it outputs probabilities for all words, and then you choose the word which has the highest probability. Okay, so let's now look into this box, this language model. So how does GPT-3 work? So GPT-3 is a so-called Transformer-Decoder. So this transformer model has been invented 3 years ago by Google and has really transformed the field of natural language processing. And interestingly, GPT-3 only uses a decoder and not the encoder architecture. That's one thing where it's already simpler than the previous models. And a decoder, so a transformer decoder is a stack of decoder blocks. And each decoder block consists of a attention mechanism, or in this case, masked self-attention mechanism, and followed by a feed-forward neural network. I will not explain what a neural network is. I will assume that you all know that. It's another simplification. So there are no recurrent neural networks like LSTM or so, just a feed-forward neural network. So GPT-3 is much simpler than some of the previous models. It's just enormously big. Okay, so let's look at this attention mechanism. So that was the key to get the performance out. So traditional sort of old language models, they look at the current word, like it here, and then they look at a couple of previous words. And the problem is, if you look at only a couple of previous words, say 2 or 3, you can't get the context right. So the it refers to the robot, but if you only look at the previous 5 words, it isn't captured. If you look at too much of the context, then you don't have enough statistics in order to learn. So that's a real problem. And the self-attention mechanism does the following. It looks at a much larger context potentially. And in the case of GPT-3, it's more than 10,000 words. But then it pays attention just to a couple of words. So you see here, it looks at a so-called similarity, or maybe one should better call it sort of relationship or so between the words, because I mean, it and robot is not really similar, but is a mathematical similarity relation. And so then it assigns probabilities to all these words. So for instance, it believes that it is related to robot and a little bit to A. And then it combines them as a weighted average and then passes on not the word it, but sort of this average. So mostly it passes on the robot because it refers to the robot. And indeed, it doesn't have only one self-attention mechanism, but a couple. I think it's 128. So it can pay attention to 128 words in the past and then make a prediction. In this case, the next one will be 5. So that's all good, but neural networks cannot deal with words. They only can deal with vectors and with real numbers. So what you have to do is you have to encode words by vectors. And what you do is, well, you assign each word a vector. So this is just an example of three-dimensional spaces. And what you want is that similar words become similar vectors. I mean, if you look at the characters like king and queen, I mean, these words character-wise are totally different, but they have similar meanings, or they should be close in space. And if you do that well, you can do even more. You can so do arithmetic. For instance, I mean, we know sort of man to woman is the same as king to queen. And so you can take the word king or the vector, add woman and subtract man, and then you get out queen, which is really nice. Or if you look at capital cities and the country, linguistically, they have usually nothing to do with each other. But if you embed them properly, you take a country, shift it a little bit down to the left, and you get the capital city. So that is really neat. And one special feature about GPT-3 is that it just doesn't have one word embedding, but has a lot of special purpose word embeddings, and they are also trained in the training process. Okay. Next, what we need is there are lots of words, and some words are very rare, and especially in languages like German, where you can concatenate words, compound words, and we have to do something with rare words. And what you do is you want to break that up in subwords. And there's a very nice method which is called Byte-Pair Encoding to do that automatically. And then, for instance, you cut lower in low and ER and these endings. Okay, that's a pre-step you do before you do the embedding. Okay, and finally, the order of words matter in nearly all languages. So we need to encode that somehow, and that got lost sort of in the previous steps. So what GPT does is it adds to each word vector, it adds a positional vector. Let's think about a watermark. It watermarks these vectors. And so the last word gets a vector added W1, and the second last W2, and so on. And then this vector also contains positional information. Okay. And finally, GPT-3 is insanely large. And that is sort of another secret sauce. It was trained on 300 billion words. That's about 1,000 times what a human can read in its lifetime. It has 175 billion parameters. That sounds a lot and is a lot, but actually it's still smaller than a mouse brain. So we have a way to go. It has around 100 layers, which is quite interesting, which is or should be larger than the number of layers a human brain has for interactive tasks, because the neurons are very slow and we know that humans can react within a couple of 100 milliseconds. So it's probably deeper than a human brain for interactive tasks. It has a huge context of over 10,000. I mean, it's not words but tokens, but roughly speaking, it's about 12 pages of text. So it can focus and have short-term memory about this length, and after that it will forget. It can focus attention to 128 words, and these vector embeddings are not three-dimensional, but they are 700-dimensional. And well, it did cost a couple of $1 million for training the network. But once it's trained, it's very cheap to apply because there's no fine-tuning or online learning going on. So it could probably write a whole book in $1 or so of electricity cost. And so it has been trained on one of the largest supercomputers of Microsoft with 10,000 GPUs and 100,000 CPUs. And it seems that more data, larger models, more compute, you get more out of it. And if you look at the graphics, it doesn't saturate yet. I mean, we have a problem with more data. I will come back to that later. But the GPT scaling works really well. And as I mentioned, simpler works better. So there are no encoders like in the original transformer, and there's no recurrence. Okay, so how do you use actually GPT-3? So what you do is, once it's pre-trained, which is very expensive, then you just prompt it with a little bit of text up to 10 pages or 12 pages, and then it will continue. And you look at the output. And as I said, there's no fine tuning going on to the task. So how does GPT-3 know what to do? Well, I mean, sometimes it's obvious. If you give it an initial piece of text and you want to, a continuation, you just give it the text, a robot must obey. And maybe human is a natural word, or the orders of a human. So it just continues. That's a very natural. Or you give it instructions or questions, like, what's the capital of Germany? And it can answer that correctly. If it's a little bit more complicated, you can give it demonstrations. You also do that often with humans, right? You give a couple of demonstrations. That's often much more effective than giving some abstract instructions. So for instance, if you give pairs of German English words and then another German word, and then it knows that it has to translate. It's more or less how to interact with a human and get the human to do something, at least verbally. Okay, we hopefully have all seen the impressive performance. I will not go really into that, for text summarization and question answering and translation. And the amazing thing is that it also performed not particularly well, but that it performed at all in tasks which are not really language related, like playing chess and Go. It can do very simple arithmetic. I mean, embarrassingly simple, but for a language model, it's quite amazing. It can create mathematical formulas from verbal descriptions. It can produce functional code. So it can do all kinds of non-linguistic things, which is quite interesting. What I found particularly funny is the emulation of David Chalmers, and maybe he later tells us, whether he finds this emulation quite realistic or not, and whether he can be substituted soon. But the most impressive thing was a discussion among philosophers, including Devitt, on GPT-3, and then GPT-3's response. It's a very self-reflective piece, about 4 pages, and at least what I can say, it seems to be a perfect response. And unfortunately, I don't have time to go into it, so I really encourage you to read that later. Yeah, it is really impressive. I still, have, some feeling maybe, the author comes out, oh, it was all a prank, it was not GPT-3. It's just too good to be true. Okay, so that's the impressive part. You can imagine lots of applications. Maybe I just pick one, like, news articles, especially in some areas like, financial news or so seem to be pretty boring and follow often a standard template. But you can imagine all kinds of applications, and of course also misuses, which we probably discuss later. I want to briefly go into the limitations, so if you look into the system, and I explained it very briefly, but also you look at the performance, you see that it's not really good at causal reasoning. And if you get the pair of sentences and ask about comparing sentences, it's not really good. Logical inference is not really good. It's not designed for bidirectional tasks. For instance, if you have a missing word in the middle, it can't do that because it's that was the masked self-attention. It only pays attention to the past and not sort of to the future. A big thing which is missing is a sequential decision-making part. So it cannot really plan ahead, and it doesn't have any intentions. And there's a grounding problem. It's only trained on text. I'm always unsure if the grounding is really important or not. Views differ on this matter, so maybe we can discuss it later. And I mean, if you want to apply it in practice, GPT is quite unreliable. Sometimes the output is amazing, but sometimes it's just garbage. And for fun, that's not a problem, but for serious applications, that's not tolerable, and that needs to be somehow addressed. I also mentioned it's super expensive to train, so it's 300 zetaflops. I think that's the first time I use zeta, which comes after exa. I converted that. That's about 1 month of human brain activity. If you assume a standard 10 to the 17 flops for a human brain. So we're getting sort of in the human regime. But the sample efficiency is also terrible. I mean, it was trained on 1,000 times the word a human ever reads, but deployment is super cheap. And anyway, I'm not worried about the cost because computers get cheaper, tailored hardware, more efficient algorithm. So this will come down naturally pretty quickly. Okay, so let me now go. I have still a couple of minutes left to some philosophical questions. So the title was, is GPT-3 close to AGI or something like this? So let me break that down into artificial, into general, and intelligence. Well, the artificial seems to be obvious. Obviously, we have created this, so it's artificial. But well, I mean, there's a couple of megabytes of code, but it has been trained on nearly a terabyte of human text. So maybe it's more human-like inside, right? It's 175 billion weights, which are based on human knowledge, and just a couple of megabytes of codes. So maybe it's more natural than artificial. One can argue about it. Is it general? Well, yes, it has impressively broad applications, but also no, I showed you already sort of the shortcomings. And I mean, if you think about particular applications, like, I mean, it cannot even empty a dishwasher. I mean, forget about the robotics problem. Take a virtual robot in a virtual environment, put it inside the head of the robot, it will not work, right? And even doing a text declaration or proving theorems. So it's all things that humans can do. Maybe humans cannot prove theorems, only mathematicians, but emptying dishwasher and text declaration, most people can do. So there's still a way to go for being general as a human. And with intelligence, well, I think we should say yes, because if you look at the output of GPT-3 and say this is dumb, then we have to label a lot of human activities as dumb, which would be pretty insulting. On the other hand, it's also extremely limited with creative thinking, analytic thinking. So it has a lot of knowledge, more knowledge than every single human, but knowledge is not the same as intelligence. So people often get confused. It's very knowledgeable, but intelligence is still somewhat limited. Okay, intelligence is a contentious concept, and rather than going into formal definition, which is my research area, what you could do is you could list the traits which you usually associate with intelligence, like reasoning, creativity, understanding, and so on, self-preservation, learning, and so on. And you can ask, is GPT-3 having these traits? And if you see, there are a couple of greens, right, which means yes, essentially, but there are also a couple of reds, more reds than greens. So still a lot of traits which we usually associate with intelligence are missing. So the more philosophical questions my colleagues hopefully discuss, like consciousness, self-awareness, qualia, and so on. So that becomes more murky. With consciousness, who knows? I mean, is David conscious? I don't know. So with self-awareness, that seems to be maybe a little bit more crisp. And if you look sort of into the system, I would say probably no. But then if you read this text, which I mentioned before, this 4 pages of self-reflection, I would say definitely whoever wrote this is very self-aware. So behavior-wise, GPT seems to be quite self-aware. With qualia, I would say no, because I strongly believe that you need some form of reinforcement learning architecture, some reward signals, sort of the carrot and the stick, in order to feel pain. And this is missing in GPT-3. Okay, let me skip that. That is some of the quotes from this text, what GPT-3 thinks about itself. And I think that's a pretty good self-assessment. Maybe it is just plagiarized from what philosophers said about GPT-3. I didn't check, I cross-checked it, so maybe somebody else did, whether everything is plagiarized from my colleagues or from GPT-2 earlier. Yeah, lots of other philosophical questions you could ask about AGI. I will not go into that. I think many of these hard questions, that would be sort of my meta answer, and maybe discuss it later. I think many of the philosophical questions will be unanswerable forever, objectively, and many of the social questions we will probably just choose whatever suits us best. in the end. Well, what next? Larger models, more data, but we already reached the limit of available English text. So there's a limit to more data. Larger models, we need to wait for more efficient algorithms or faster computers, so you can't do that tomorrow. But we have lots of other languages, so for translation, it could be useful. Different modalities, so vision is not in GPT-3, and many people argue that this is very important to get a more direct experience of the real world. More data efficiency, and what I would argue, reinforcement learning is the most important ingredient, well, non-ingredient, which is missing in GPT-3 to make it an intelligent reasoning agent. The lifelong learning and online and the lack of fine-tuning, I think that's just a technicality. I mean, easily. Okay, that's sort of the end of GPT-3 and AGI. Let me remind you that of my own views and not the views of any of my employers. And if you're interested in my work, best just go to my website. I run a compression contest called the Human Knowledge Compression Contest. And you know, maybe some of these transformer models would be able to win part of this 500,000 euros. That would be really cool. And my core research is about mathematical foundations of AGI. I don't want the audience to bore the audience with mathematics. So this is this equation. And let me just say, if we had a computer fast enough, but no computer will ever be fast enough, then we would have solved the AGI problem already. We just put that into the system, and I have proven that this is the most intelligent system. Unfortunately, we will never have the resources, so we need to approximate that, and that's sort of a big research program.